You've chosen the presentation for Life Cycle Cost Analysis, Topic 4. This is a part of the subject Construction Economics 1. And by doing this subject, you're going to be able to identify the major components of life cycle costing and should understand the benefits of life cycle costing as a tool for considering alternative designs, products or materials. Quickly summarise some of the course requirements. If you have any questions during the course, please contact me. You can do that via the Q&A forum on Moodle or email me directly. Otherwise, you can post as a discussion with other students on the student discussion forum. Be very clear about assessment submission dates, presentation and assessment format. And remember, this PowerPoint presentation is merely a summary of the subject. It's not here to replace the study guide, the text and other reading resources. By considering the components of life cycle analysis, this is a diagram I often use when talking about life cycle generally, because a lot of the costs in constructing the building, as you can see there, the capital cost, and that's the cost that covers the design, construction, commissioning, capital servicing and so forth. The design, when you look at it, this iceberg here shown in the diagram, a lot of the real costs, the maintenance costs, operating costs, minor new work and term replacement is the bulk of the real cost of owning the asset and building the asset. When you look at the life of the building overall. In fact, an interesting note is that generally hospitals that are built that are a relatively large investment for governments and the public. Within 2.5 years, it's very often that the running costs, including all staff, energy and everything that goes into the hospital, within 2.5 years, the capital cost of providing the hospital is already been met. The main driver with life cycle costing, and by looking at this subject, you're really wanting to get away from the topic, that the fact that the owner plays an important role in looking at the costs and the payment of the asset and building today, the capital cost today. Those decisions that he or she makes today could have a long-term bearing over the lifetime of the building and asset operation. It's important also to try to define the life of a particular project or components of the project, certain materials or certain building elements. But having said that, it actually gets very difficult, not just because of data that you need to forecast and look for how long a material or a building component will last. But the practice in doing so, we have to consider several things, such as economic life, which is the period over which the occupation of the building is considered to be least costly alternative for achieving a particular objective. Also the functional life, where that building or the component of the building ceases to function in the same purpose for what it was really built. The physical life as well, which is the duration that the building or components of the building actually collapse and they're not usable anymore. Technological obsolescence, and this is occurring a lot, from anything from lift controller parts right through to shading, air conditioning, that type of thing, where the component is no longer superior and alternatives and replacement needs to be undertaken. And as well as social and legal obsolescence, where human desires or legislation actually dictates the replacement of components of a building, and that is definitely non-economic reasons. Examples of these could be fire codes, asbestos legislation, things like this. The diagram here demonstrates the percentage of cost over the life of the entire building. So clients can establish the best value for money solution to meet their needs by considering where the money is, where the costs are likely to occur. An example might be with an operation to phase costed out, where, as I said previously, hospitals are typically operating over a 2.5 year interval acquisition cost, phase out costs. And also now it's important to note that it's much more important now to consider reduced emissions. There's greater emphasis on sustainability and the need to further reduce operational costs. As I said earlier, the life cycle costing relies on an extensive bank of cost data, area provisions, physical recordings and so forth. A lot of this data, because we're projecting it out over time, it often needs to be brought back to a common denominator, something where we can compare apples for apples. Using the life cycle costing process, it's necessary to understand and adopt the principles of discounting, which is the value of future receipts and payments, basically. And really, even ignoring inflation, if we're offered $100 today or $100 next year, it would be more profitable to receive the sum today, merely because it's a bird in the hand worth two in the bush, but because the sum is received and invested now, it will be worth more later. And similarly, if we're offered the choice of paying $100 now or paying it next year, it's better to choose and make that choice of payment now. And that's how this present value formula works. So in other words, in order to quantify the time impact of future receipts and costs, the cash flows are converted into equivalent present values. And this formula here, FV, where FV is the amount to be spent or received at a point in the future, 1 plus R. R is the discount rate applicable to the chosen intervals, and N is the number of intervals between the present and the future, example, the number of years. So an example might be $100 in 3 years' time with a discount rate of 10% would have a present value of $75.10. We can work through these more, and there's more work through examples in the study guide. The life cycle analysis and life cycle costing is also a very important tool and a very important concept when considering alternatives, as I said earlier, in the design phase. So in this case here, a very simple example I've used: do we renovate or do we build new? I think it's important with life cycle costing to get some fairly basic principles or practices. I've identified them here because they sound simple, but believe me, once you start looking through life cycle costing and start doing simple calculations, you'll come back to it and you'll wonder what the assumptions were. So say here, show all workings and assumptions. It's really important what that might be, what that interval and so forth. There is software out there that you can adapt, but you'll find that in a lot of situations, they're very different things that you're trying to life cycle cost or trying to bring back to a common denominator. So in most cases, an Excel spreadsheet is still the best way to actually do these calculations. And as I said, show all the given information: options, time, annual costs, materials, who's given you the information, where you've sourced it from, that type of thing, and all those workings that go with it, all the calculations. And the last but not least, define the options with the year, the escalated total cost, discount factor, and total present cost. Workings for a simple present value life cycle cost calculation should actually look something like this, which is quite often different to a program where you throw the numbers in, what your options are and what your assumptions are, and it spits the number out at the bottom. This is much better because you can actually see where you are in that duration and actually make changes or change some of the assumptions. So this is option 1. There is an option 2, but I'm just showing you this so you get some idea of how that layout and calcs are to be presented. And I've put a slide up here: why accept a higher or capital cost? And it seems to be something that I'm continually trying to provide justification to building owners about. And a lot of it, it's difficult. They've been provided with, or they've got some idea of what a cost will be themselves, or a capital outlay. But once you start looking at it from a life cycle perspective, there's many other issues as well. So prestige, aesthetics, things like practicalities in its maintenance and repair. It's a big issue. You can spend a lot of money once we start moving out of that 10-year period with a building. all of a sudden things are not that new anymore, and some of those repairs, if there's chillers in wrong parts of building, if the building had a little bit better design with plant rooms, access to windows for cleaning, those type of things, it becomes costly to repair and maintain. Obsolescence as well, trying to keep those components of the building and where you can, ensuring that obsolescence really isn't going to be a problem, and sometimes it is, even within 6 years with simple components such as fire panels that there's no parts for. Technology's changed on. You can get around that at the initial design stage. As I said, the source and nature of cost data, it's often difficult to make an informed decision on why you're putting in so many years for a life of a material and so forth, or a component of a building. And there's many scenarios that can be thrown at you. A building that you're looking at the moment, or an asset at the moment, may be in a unique position, and so you're reliant on really information from the manufacturer's data and specification. So even the lives of commonly used materials like paint show some surprising variations, and are influenced by a number of range of factors. You know, that it could be the type of paint, number of coats, the preparation, the environment where it is, atmospheric conditions. It could be a seaside location. It could be next to an industrial area, or a very trafficable inner city location. And the degree of exposure too, even to UV or rain. So all these type of things need to be taken into account. The type of payments that have been the method of paying for the material in previous studies, and also aspects associated with wear and tear as well. How the building's being used, what's its everyday program. To the end of topic 4, life cycle cost analysis, and it's a good opportunity now to read through the study guide, familiar yourselves with the text and any other reading that is with this particular topic, and work through the workbook activities now, rather than leaving them to the end of the course. If you have any questions, you can post them on the Q&A part of the forum, or otherwise post them in the general discussion with other students, or otherwise email me.